Today we're going to be learning how to solve systems of equations by graphing. What is a system of linear equations? A system of linear equations contains two or more equations, such as y equals 3x plus 1 and y equals 2x. And the solution of such a system is going to be the ordered pair that is the solution to both equations. For example, if you have y equals 2x and y equals x plus 1, we would have the ordered pair as 1, 2 as the solution to both of these equations. And you can go ahead and check that by plugging 1 and 2 in both x and y for the equations. So for the first equation, we would have 2 equals 2 times 1. And that is true. And then for the second one, we would have 2 equals 1 plus 1. And that is also true. So that proves that it is the solution to both of them. In order to solve a system of linear equations, you're going to graph both of the equations into the same coordinate system. And then once you have both of the equations graphed, the solution is going to be where both of the points intersect. And that would be right here. So let's go ahead and do an example with this. So we're going to have the equations y equals 2x plus 2 and y equals x minus 1. Looking at both of these equations, they're both in slope-intercept form of y equals mx plus b. So we can look at the first one and show that our slope is going to equal 2 and our y-intercept here is going to be 0, 2. So we can use that to graph our equation. So we'll start with our intercept at 0, 2. And using rise over run, since we have our slope, we can go up 2 and over 1 to establish some points on our line. And then we're going to connect all these points. And we're going to label our first line here as y equals 2x plus 2. And we're going to go ahead and change colors, that way we can see the difference between our two equations. So for our second one, our slope here is going to be 1, and our y-intercept is going to be at 0, -1. So we can go ahead and graph that, starting with our intercept at 0, -1. And using the rise over 1, we can make some points on this line. Connecting our points with our line and labeling it here as y equals the x minus 1. Now to find the solution, we have to look where both of the lines intersect on our graph, and they're going to intersect right here at -3, -4. Therefore, the solution to this system is -3, -4. So we're going to do another example. We're going to start off with our first equation in red again. Looking at these, they're both in sloped-intercept form, so we can go ahead and write our slope as -3 and our y-intercept as 0, 2. So going to our graph, we'll start with our intercept at 0, 2, and then graph some points on this line, so we can go down 3 over 1. Oops. There we go, and we're going to connect our points. And we're going to make sure we label our line as y equals -3x plus 2. We can go ahead and we're going to change our colors again to green. You guys can use colored pencils or even colored pens to make sure that you write your lines in different colors so it's easier to read. So here for our second equation, we're going to have our slope as 2 and our y-intercept at 0, -3. So going to our graph in green, we're going to graph our intercept here at 0, -3, and our slope was 2. So we can go up 2 over 1. And there we go. We're going to connect our dots. So the green line is the y equals 2x minus 3. Looking at where the two lines intersect on our graph, we see right here they are going to intersect at 1, -1. So since that's where they intersect, that will be our solution to this system at 1, -1. We're going to move on to our third example. So we're going to go back, keeping it consistent as our first line in red. The first equation is already in slope-intercept form, so we have our slope here at 1/2 and our intercept at 0, -3. So we can go ahead and graph our first equation here at 0, -3, and then we use the rise over 1, up 1 over 2 to establish our points. Connect them and make sure we label our line y equals 1/2 x minus 3. Now here for our second equation, however, it is not in slope-intercept form, so it's going to be easier for us to write it that way so we can solve it. So we have to start by isolating our y, so we're going to move the 3x to the other side, so we're going to have the 2 minus 3x equals 2y, and then again to isolate our y we have to divide both of the sides by 2. Therefore we're going to get 2 over 2 minus 3/2 x equals our y. Now we can rewrite this so it looks y equals with our slope first at negative 3/2 x, and then the 2 over 2 is just going to simplify to plus 1. So therefore our slope will be the negative 3/2 and our intercept is going to be at 0, 1. So that way we can use that information to graph this line. So here we have 0, 1. So we're going to be finishing our points down 3 over 2. And we can draw our line, making sure we label it so we have y equals the negative 3/2 x plus 1. So looking at our graph here, both of the lines are going to intersect at 2, negative 2. Therefore, that will be our solution to this system of equations. So looking at our fourth example here, we're going to start and both of the equations are in slope-intercept form. So for our first one, we have our slope as 1 and our intercept at 0, 1. So we can go ahead and graph our first equation on the line on our graph here. So there we have 0, 1, and we're just going to graph a few points on our line. Draw that out. So in red here, we're going to have y equals the x plus 1. And then we're going to go ahead and graph our second one in green. So since it's also in slope-intercept form, we have our slope as 1 and our intercept at 0, 4. So we're going to go ahead and graph this one on our line as well. So here's 0, 4. With our slope of 1, we're going to graph some other points on the line. Connect them out. And then label this one as the y equals x plus 4. Now here we have a unique case. Since both of them will have the exact same slope here as 1, the lines are going to run parallel to each other, therefore they will never intersect. So here the special case is that there will be no solution to any system of equations that have the exact same slope since they do not intersect, since they're parallel lines. Thank you for watching, and here are my sources.